Okay. So a car starts from rest. It acquires a speed of 25 meters per second after 20 seconds. The distance moved by the car during this time is okay. So the question requires that we find the distance moved by the car. But the statement, okay, of start from rest, come to a stop, come to rest, this phrase is super important. You have to pay attention to them. So once the information is about the car starting from rest, it means initial velocity u is equal to 0. First, it acquires a speed of 25 meters per second. So it then accelerated, and so the final speed is 25 meters per second, occurring within a time of 20 seconds. Now, the distance moved by the car during this time interval is, so we are looking for S. Are we there?
Yes, please.
Good. So, in such a situation, you decide based on what you have, which of these equations would help you. Can it be one? Yes, I want you to judge. Can it be one?
No.
No, please.
Can it be two?
Yes, please.
Yes.
Can it be three?
No.
You see, in this case, either equation 2 or 3 can help us. But you would have to use one of them to find an unknown, which will help you apply equation 2 or 3. Correct? Because in each one of these two equations, you have no idea of the acceleration of the body A. So if you pick this, you will need acceleration. If you pick equation 3, you still need acceleration. And so it's obvious equation 1 would help you, find the acceleration, which will eventually enable you find the distance, right? So for this particular question, we will use two of the equations of motion to help us find the unknown distance. Are we okay?
Yes.
Okay.
Please.
All right. So assuming that using equation 2, S is equal to ut plus half at squared. You still need A is equal to V minus Q on T, which is equation 1, in order to use equation 2. So V is 25. U is 0 divided by 20, giving you an acceleration of 1.25 meters per second squared. Once you have the acceleration, you can be accelerating, okay, in solving the word. So S is therefore equal to U. U is 0. The initial velocity is 0. And so this part of the equation goes to 0. So we only have S is equal to half at squared, which is equal to half times 1.25 times 20 squared. And this will give us 250 meters for the distance traveled by the car. Any question?
No, please. No, please.
Okay. We can also use equation 3. And let's see how we
go over again.
go over again. Okay. So if we want to use equation 2, which is distance is equal to, or displacement is equal to ut plus half at squared, you will still need the acceleration because you have u, you have t, but you don't have the acceleration. So here you need equation 1 to help you get the acceleration. So you have to make acceleration the subject from equation 1. A will be equal to v minus u all divided by t. Knowing v, knowing u, knowing t, substitute them into the equation and you have acceleration A equal to 1.25 meter per second squared. Okay, now come back to use your chosen equation. But because the initial velocity is 0, this part of the equation goes to 0. So you end up having this. S is equal to half at squared. Okay, substitute your value. Half is a constant times your acceleration value times the square of the time. And then when you put them together, you have 250 meters. Okay, if you want to use equation 2, then you have to make, 3, then you have to make S the subject. Help me make S the subject from equation 2. 3. Help me do that. From equation 3, let's make S the subject.
V squared.
So first you have to send v squared to the other side of the equation. So you have v squared minus u squared is equal to 2as, isn't it?
Yes.
And what again will you do?
Divide both sides by 2a.
So that's divided by 2a. So I have s is equal to v squared minus u squared all on 2a. You have u, you have v. So substitute your values. V is 25 minus u is 0 divided by 2 times acceleration. Because you already have the acceleration, just go ahead and substitute it. 1.25. So S is equal to 25 squared over 0.5, 2.5, isn't it?
Yes. Yes, please.
2.5 is 25 times 10 to the power -1. So I have 25 times 25 times 10 all divided by 25. This and this cancels out. I have 250. The same value as this. So this is the problem of the day. So beautiful. All right. Let me get you a couple of questions to try. Give me a second so I could pick a question for you. Ready?
Yes, please. Please.
Okay, first one. A car travels 2.1 kilometer south. A car travels 2.1 kilometers south in 7 minutes.
Celia, please, you said 2.5.
2.1. 2.1 kilometer south in 7 minutes. In 7 minutes. First question.
Is 2.1 kilometers south of start.
A car travels 2.1 kilometers south in 7 minutes. In 7 minutes. Find its velocity in meter per second. Find its velocity in meter per second. And question 2. Are we there?
Yes, please.
Okay, finish this. You finish this. I think I'll take shots of the second question and then send it to the platform, okay? Hello, Gloria. Gloria.
Mr. Dia, please, I'm coming. I made a mistake.
Okay. I want to send the second question to the platform. Okay, so I've sent the second question too. So the second question is on the platform. Okay. Akuya,
Sir, please, can I say the answer?
uh, you just go ahead and answer the other questions I've posted, right? Okay. Hi, class. You see, I am collecting the data concerning the number of students we handle on for the online. Okay, and I have to report that to management. So please, as I indicated on the platform, get me your names, your class. If you are not a GH student, let me know your name in full and then your school. Okay, because it's a database we are collating for online classes. All right. Okay. So treat,
Yes,
as I
please.
said, treat that for me as urgent as possible. Send me a private message on to me with your name and all those details for me. So important. I have to get it for them by tomorrow. So I'll be waiting for you um today. Okay. I've realized a lot of you have done that, but the rest of you should quickly, reach out to me so I can finish it and then wash my hands of it before um Thursday. Okay, so I've sent you two questions. I've sent you two questions, two other questions. Just enjoy them. Okay. All right. So as you go through the question, I'm also looking at sending you a question which will engage you because I'll use the about 20 minutes. Okay, you use 20 minutes for solving a problem. So because we are doing practicals for the form praise. So I'll take leave of you, but I'll occupy you with the questions, which I'm going to take short of it and then send it to you on the platform. Okay. All right. Okay, so I'm forwarding the questions. In fact, it's quite a lot, but I think it will help you understand the concept taught so far so well. Okay. But when you get the question, please answer it as it appears, okay, in the question itself, the order with which the questions are presented, okay, in what I'm sending to you. And that would make marking easier for me. So do so for me. We have about 130. So let me quickly send that to you so it can engage you, right?